Hello everyone. In this video we are going to begin our discussion on how to formally prove that two triangles are congruent. There's going to be multiple theorems that prove the triangles are congruent over the next several videos. The first one is side-side-side congruency, or SSS. If three sides of one triangle are congruent to three sides of a second triangle, then we know the two triangles are congruent. Now think about what that means, two triangles being congruent. From the previous video, congruent figures are figures where they're the same exact shape or size. The angles match up and the sides match up. Okay? So if we can prove that all three sides are congruent, then we also know that the triangles are congruent, therefore all the angles also have to be congruent. Okay? So, in example 1, determine if side exists. Okay? So, in example A, we've got two sides that both have a length of 9. Since they have the same length, their sides have to be congruent. So we have JL is congruent to LM. That's given to us based off this diagram. All right, we are also given these two side lengths have a length of 8. So we know that JK is congruent to MK. I should be putting lines above these. Sorry. Okay. Now, at first glance, you might be like, well, that's all that we're given based off of this diagram. However, notice, I'm going to get a different color to see this, not a different blue, a different color entirely. Notice LK. LK is shared between both of those triangles. So LK is congruent to itself. Okay? So this is shared. It's a shared side. And if you remember from the previous video, we can use something called the reflexive property to say that something is congruent to itself. All right, well, notice what we've got here. We've got side, side, side. So yes, these two triangles are congruent. All right, triangle LJK. The order is important. I start at L. I go down the 9 side, down the 8 side, up the shared side. Okay, so triangle LJK is congruent to triangle. So I go down the 9, so I start at L, I go to M, I go down to K, and then I go back up. So triangle LMK because of side, side, side. All right, what about an example 1B? Well, we've got two sides are congruent. We've got ST congruent to WV, and we have RT congruent to WT. All right, but what we don't have are these third sides. Okay, is there any way RS is congruent to TV? Is there any way we can say that? No. So, no. Okay, there's not enough information. We don't know if RS is congruent to VT. There's no math statement that we can make that is going to show that these two segments are congruent. Okay, now what about in example 2? This is where we're going to get into these formal type of proofs where we have to make an argument for why these two triangles are congruent. All right, so we are given in the diagram FJ is congruent to HJ. And we are also given that G is the midpoint of FH. We want to prove that triangle FGJ is congruent to triangle HGJ. We want to prove that these two triangles are congruent. All right, so how are we going to start with this? Well, we are always going to start by our givens and what that gives us. All right, so we are given that FJ is congruent to HJ. Okay, and how does that help us? How does that help us? So actually, hang on one second. I'm going to figure out how to write this. All right, so we are given that FJ is congruent to HJ. All right. And then in parentheses, I'm going to say what math reason do I know for that? All right. FJ is congruent to HJ because that's given to me. We might as well use our givens. That's free information. All right. Now, what is that though? That's a side. Okay. We already got one of these sides that are congruent. All right. Now, what does the next given say? It says that G is the midpoint of FH. So G right here is the midpoint of segment FH. So what does a midpoint do you think? Cuts a segment in half. So I like to mark up my diagram in addition to writing the formal stuff. If G is the midpoint, that means FH is cut in half. That means these two sides are going to be congruent to each other. All right, so I can say, I can say that FG is congruent to HG. And why did I know that? What's my math reason for that? Okay, how did you know that those two things were congruent? Well, that's the definition of a midpoint. Or you could say because G is a midpoint. What's your math reasoning for knowing that these two segments are congruent? G is a midpoint. All right, now what does that give us? That gives us another side. So we're so close to side, side, side right now. We just need the third side. Okay, so why does it make sense? This is the third side, JG. What do you notice about JG? JG is shared between both triangles. Okay, so JG is going to be congruent to itself. So JG is congruent to JG because it's a shared side. Or you could say the formal reasoning is the reflexive property. Okay, so JG is congruent to itself. They share a side. Therefore, that side is automatically congruent to itself. All right, so that's my third side. I'll stay consistent, use the same color. Okay, so we've proven that all three sides in these two triangles are congruent to each other. Therefore, triangle FGJ is congruent to triangle HGJ. All right, my reasoning for that, side, side, side. Okay, we were able to prove that all three sides between these two triangles were congruent using math as facts, using our given, using the midpoint and interpreting what that meant, looking for shared sides, analyzing this diagram, we were able to prove that these two triangles were congruent using side, side, side. All right, so this is where we're going to be making formal proofs and making an argument for why two triangles are congruent.